Good evening, everybody. Today we will discuss the general chemical properties and reactivity of the interhalogen compound. Interhalogen compounds are more reactive than ordinary halogen atoms. Since we know that the bond between the halogen atom in interhalogen compound are weaker than the bond between the identical halogen atom, and while we are comparing the interhalogen compound between the chlorine and fluorine and bromine and fluorine and iodine and fluorine having the same number of the fluorine atom, most reactive one is the ClFn, which is greater than BrFn, which is greater than IFN. Then as the number of the halogen atom increases, the reactivity also increases. See the example. If you are comparing the interhalogen compound between the bromine and fluorine, the interhalogen compound is most reactive one is the BrF5 greater than BrF3 greater than BrF. And the ClF3 is one of the most reactive substance known and good fluorinating agent than the fluorine. See one example. If the uranium element react with ClF3, we will get UF6. That means we have fluorinated the uranium element and also ClF it is formed. Now, next is the reaction with water. The interhalogen compound XX dash, that means the first type, react with water and to form the most electronegative atom in the interhalogen compound react with hydrogen in the water and to form the hydrogen halide plus HOX, hypohalous acid. And the next type, that is XX3 dash, react with water and to form hydrogen halide. As we discussed earlier, the most electronegative atom react with hydrogen and to form 3HX dash plus halous acid HOXO. And the third variety, XX5 dash, react with water and to form HX dash, that means most electronegative atom react with hydrogen and to form an halic acid is also formed. Next variety is the XX5 dash XX7 dash, react with water and to form HX dash plus perhalic acid. Now we are moving into the example. ICl react with water and to form HCl plus HIO. Similarly, ICl3 react with water and to form HCl plus HiO2. BrF5 react with water and to form HF plus HbRO3. And IF7 react with water to form HF plus H5IO6. Now the reaction with alkali. Interhalogen compound react with base and to form the first group element react with most reactive, most electronegative atom in the interhalogen compound. See the example, ICl plus NaOH. Na react with Cl and to form NaCl plus NOI plus H2O. So similarly, BrF5 react with KOH and to form KF plus KBrO3 plus H2O. Reaction with alkali metal halide. Interhalogen compound react with alkali metal halide, for example KCl, and to form K plus ICl2 minus. That means a complex is generated. Next, reaction with addition reaction. Interhalogen compound act as a we can add the interhalogen compound in a multiple bonded the organic compound having the multiple bond. See the first example, CH2 double bond CH2 plus ICl. We will get CH2Cl and CH2I. Now we are moving into the shape of the interhalogen compound. We have studied the four different varieties of the interhalogen compound. CLF, CLF3, BRF5 and IF7. So CLF shows a linear geometry and CLF3 shows a T-shaped geometry and BRF6 is square pyramidal and IF7 is pentagonal bipyramidal. Now we will discuss the individual interhalogen compound in detail. First one, the structure of the chlorine trichloride fluoride CLF3 molecule. So before discussing the structure, first of all we should mention the ground state electronic configuration of the central metal atom. See, in the interhalogen compound, our central metal atom is the bigger one. So here in CLF3, our central metal atom is the chlorine. See the ground state electronic configuration of the chlorine: 2s2, 2p5, then 3d orbital are empty for chlorine. Then in the excited state, we have to generate the 3f bond. So for that we have 3 half-filled orbital. We require the 3 half-filled orbital. So one of the electron in the p orbital is excited into the d orbital. And thus we have 3 half-filled orbital and 2 fully filled orbital. So the hybridized orbital, hybridization is sp3d. So it is existing as a trigonal bipyramidal structure. See the trigonal bipyramidal structure. In the first one, I have shown the structure which is in the left hand side, in which the 2 lone pair of electron exist in the equatorial position. Whereas in the geometry which is in the right hand side, in which 2 lone pair of electron exist in the axial position. Which one is more favorable and which one is least repulsion? So the figure which I have shown in the left hand side having the minimum repulsion and it exists in the T shape. This is because if the lone pair of electron exists in the equatorial position, we can reduce the repulsion, and the bond angle between the CLF bond is approximately 87.4 degree. That means it is close to the 90 degree. Whereas in the if the lone pair of electron exists in the equatorial axial position, it requires the maximum repulsion. So that's why the preferred geometry is the first one. That means left hand side. The geometry I have shown in the left hand side, and the geometry is T shape. Next we are moving into the another molecule, that is ICl3 molecule. When we compare to the ClF3, the ICl3 exists in a dimeric form and chlorine bridged to the iodine atom. There are two bridging and 4 terminal chlorine atom in ICl3 dimer. And the iodine exists in sp3 hybridization and the molecule are planar in geometry. See, the bond length between the I and Cl in the bridged bond is found to be 268 picometer, whereas in the terminal position ICl bond is found to be bond length of the ICl bond is found to be 238 picometer. And see the bond angle between the iodine and chlorine in the bridged one, it is only 84 degree, whereas in the terminal position it is found to be 94 degree. So I hope that you understood the general properties of the interhalogen compound, also the structure of the ICl3 and ClF3. Thank you.